In a conventional home, water follows a simple path. It enters as drinking quality water and leaves as wastewater. But most of that water was never used for drinking. Every shower, every laundry cycle, every hand wash produces a stream that is still relatively clean. This is greywater, and in most buildings, it disappears into the sewer within seconds. For environmental engineering, this is not waste, it is an untapped internal water source. The first step in recovering it is understanding where it is generated. Greywater is typically defined as wastewater from showers, bathroom sinks, washing machines, bathtubs. It excludes toilet discharge and kitchen wastewater, which contain higher organic loads and pathogens. This distinction is critical because greywater, when properly managed, can be treated with compact systems and safely reused for non-potable applications. Mapping these sources is the foundation of a closed-loop residential water strategy. In an average household, greywater represents between 50 and 70% of total water consumption. Showers alone account for the largest share. Laundry is another major contributor, producing large volumes in short periods. This means that more than half of the water entering a home can potentially remain within the building's internal cycle, but only if it is separated at the source. Without separation, it mixes with black water and becomes far more complex and energy-intensive to treat. Greywater production is not constant. It follows daily behavioral patterns. Morning peaks from showers and sinks. Intermittent spikes from laundry cycles. Evening usage from personal hygiene and cleaning. Understanding these time-based patterns allows engineers to design storage and treatment systems that match real demand. In a loop system, timing is as important as volume, because reuse requires synchronization between production and consumption. In multi-story buildings, greywater sources are vertically distributed. Bathrooms, laundries, and utility rooms are often located in different zones. Efficient collection requires dual plumbing systems, gravity-assisted flow design, minimized pumping requirements. This spatial mapping determines whether greywater reuse is practical and energy efficient. Environmental engineering at the building scale is always a question of hydraulics and layout. Not all greywater has the same quality. Shower water contains soap residues, skin particles, low organic content. Laundry water may contain detergents, microfibers. Higher turbidity bathroom sink water varies depending on usage patterns. This variability influences treatment design. Some streams are easier to treat and can be reused with minimal processing. Others require additional filtration and biological stabilization. Source mapping is therefore also a quality assessment. In new buildings, greywater separation can be integrated directly into the plumbing design. In existing homes, retrofitting requires localized solutions. Shower-level collection units, laundry-based reuse systems, compact treatment modules. This modular approach allows gradual transformation without full reconstruction. Decentralization makes implementation possible. In the next generation of sustainable housing, greywater will not be an afterthought. It will be a core design parameter. Bathrooms and laundries will be located to optimize collection. Storage and treatment units will be part of the architectural layout. Water reuse will be considered at the same level as energy efficiency and thermal performance. This marks the transition from water consumption to water metabolism at the scale of the home. Before water can be reused, it must first be understood. And inside every home, the map has already been drawn.